let's go to GitHub, and we're in the project menu, and you can see that we have a Bootstrap, sandbox, and upgrade test. This one is not actual environment that's running. It's a previous environment. We're going to create a new, well, we're going to, but we need to log in.
While you're doing that, can I ask David, like, let's say a potential new adopter or implementer of Mojaloop, they want to use this. How do they get GitLab? And how does what we have in the repos, they can use that? I think that's open source accessible to everyone, but how does that work with GitLab?
So the Bootstrap um, GitHub repo is used in order to do just that, to bootstrap the tenancy, which is a logical group of environments that you want, of mojaloop switch environments that you would want to run, having the same control structure. And so GitLab is a part of that bootstrap, and that allows you to keep the configuration of your environments in a Git repository, and that it also has a CI/CD runner component that allows you to build your environment and maintain it over time, as well as run tests and other features.
But thank you.
Uh-huh. And need the two factor authentication. Okay. So, as you remember, before I got prompted to log in, we were creating a new project. So we're going to create a blank project. We're going to keep it in the IAC group for a couple of reasons, but I won't explain that right now. There are different types of variables that can be stored and shared at a group level with all the projects underneath it. And that's the reason why we keep all of our environment repos under the IAC group. So, what is the name of our new environment, Sam?
Fintech sandbox.
Fintech
Maybe
sandbox.
we can put like an RW at the end to be more specific.
At the end?
Yeah, yeah.
Put what at the end?
RW for Rwanda.
Like this?
Yeah.
Okay. And so this is going to be the sandbox for Rwandan fintech. Right. It's going to continue to be a private project, and we'll allow it to initialize with a README. Now, I have to say that a lot of these steps for creating projects and other elements are taken care of by part of the Bootstrap process that seeds the environments. All right, so this is the module for the Bootstrap. This is where we indicate the domain, what region, and here you'll see the environments, right? And the environments are created within the same VPC as the tenancy. And that whenever you change, add or remove an environment, you need to come in here in order to create the different AWS artifacts that are needed to run the environment in. So here you see that the variable environments is a list. It's got sandbox, this upgrade test, which is not running. It's been destroyed.
Okay.
And if we wanted, we could remove this upgrade test from here, and the subnets that it was taking up before would be completely destroyed, but I'm not going to do that within this video.
Sure.
So we're going to add the name of the new project, and we're calling it Fintech Sandbox why don't we make a little bit of an acronym here?
Sure.
Does that work for you? FinTech Sandbox Rwanda? I don't know if I can hear you anymore.
Yeah, I'm thinking that looks fine. No problem.
Okay. And in order to preserve the ordering of the CIDR block assignments for these different environments, we put a little bit of ordering in here so that as environments get created and destroyed, that we don't inadvertently step on existing environments' resources.
Right.
Okay, so that is the end of what we need to do here. So we are going to go to this directory here, and maybe I'll just I'm going to do a Terraform init here. So this is the bootstrap code where, and I need to make sure that my credentials are set up correctly for this AWS environment.
Okay.
So I am going to export my AWS profile. And I'm going to do a Terraform init. All right. There was no changes in terms of the providers that we're using, so it had already been initialized. Now we're going to do a plan. And here we're going to see what changes. Now the state lock is being maintained in S3. So it's acquiring a state lock. It's checking the existing state of the bootstrap against what we've specified. And then it's going to do a diff. So the plan was to create these subnets, and there may be some tagging structure that has to be changed. But you can see here that the new environment is being added, going to create a private subnet and a public subnet. So the next step would be to apply this change.
Okay.
This is going to do the same thing. We didn't save a plan file from the last. The correct way would be to, if you're working with multiple people concurrently on the same Terraform state, then you would want to save the plan out on the plan step and then actually just apply the plan file. But here, nobody else is working, so we're just doing it a straight apply. Okay, so the output is here. It's showing all the different subnets that are created for all the environments, but we have our new subnets for the new environment we want to create. So the other element that I was talking about before is that we have the in this post config, we have the ability to seed a lot of the GitLab information. So it creates the project. It will create any environment variables that are needed ahead of time. So basically, all you need to do is take the configuration, add your new configuration for the environment that you want, like which mojaloop version you're running, and maybe change sizes of VMs or versions of other products, and then go ahead and execute the GitLab runner jobs. So in here, this should not have any changes required because we are pulling in everything from the bootstrap that just ran. Just refreshing my memory if there's anything that I need to change here. I don't believe so, because you can see we're taking the remote state. The environment list is coming from the previous module that we just ran. And so all I need to do here is go into the post config and similarly do a Terraform init just to be sure. And then I'm going to skip doing a plan. We'll do an apply. It's going to give us the opportunity to review. We're going to go to the instructions that we find in the Bootstrap repo.
Okay.
And in the main page of the Bootstrap repo, we have the README, and the README has a little how to use Bootstrap, building a tenancy. And if you click here, you'll have instructions about how to start spinning up a new tenancy using the Bootstrap repo. There is a Docker image that you can run to do that, where all the tools that you need, such as Ansible and Terraform, et cetera, are with the correct versions are all installed for you in the Docker image. I already have those on my local machine, so I am going to, and not to mention that once you start configuring the Bootstrap files, the best practice is for you to save the latest version of those Terraform files to your GitLab instance. And obviously your GitLab instance isn't running until you first create the tenancy. You have to chicken and egg problem. You have to actually run the Bootstrap Terraform in order to create the GitLab instance that you will later use in order to maintain your environments and run pipelines. And in addition to that, the GitLab instance will create projects. We'll have projects preceded so that you can also maintain the latest state of your Terraform for your Bootstrap. So I know that sounds confusing, but essentially, when you're working with a team and you want to make changes, you can apply those changes and keep track of them in GitLab as well. So we'll kind of see example of that going forward. So in any case, here are the instructions. You need to export the correct profile. Then you need to init Terraform init using the backend configuration file. And then you need to do an apply. And effectively, that's what we did previously when we ran the Terraform apply. And what I was showing as we ended the last recording was that then we go into the post config, and then we run a Terraform init as well in there. So I am going to continue along what we were doing before. And again, there's nothing new here. This is going to just say it's already initialized because I've run this before. And then the only change to what I did before was to add a var file in that points to the same backend HCL file. That was what was throwing the error before. Okay, so now it says, I am going to create some, basically a new GitLab project called this. And it's going to essentially do some configuration on that as well. So it essentially makes the GitLab experience easier. So we're going to say yes. Okay, so that is finished, and we are going to go back to our IAC. And this is the one that we had done manually. I'm going to delete that so that we don't get confused later on. Let me go to the admin here and look at the projects. And let's get rid of this one because it is going to cause confusion in the future. All right, that is gone. Now we'll go back to the project view and let's look at the projects. All right, so here's the new project that we created. And now it is essentially preceded this project. And if you look at, excuse me, the CI/CD settings, we have group variables that are already inherited by this project. And so this would allow us to easily start running the pipeline once we've added the correct GitLab CI files and configuration. Okay, so that's the next step of what we're going to do. So we've created this repo. Okay. Let's go back to the repo view and let's copy the URL for GitLab. And let me just get into the right directory. So here is where I keep, here is on my computer where I keep the different GitLab repos. So I am going to clone the repo from GitLab into this local area, local directory. And if I go into this, you'll see that all it has is a README. All right. Now we need to talk about what files are necessary from just a straight, the bare minimum files necessary in order to start deploying an environment. So we looked at the Bootstrap repo. Let's go to the IAC-AWS platform. Okay. So there's some documentation in here about, it actually points you back to the Bootstrap in case you hadn't done the Bootstrap, and other prerequisites, and talks about the pipeline ordering here and how you would access, run different tests and access the different portals. So that's a very brief description. But here, in terms of cloning the environment repository, that is where we're at right now, right? So we, and I'm going to make this brief, I'm going to go over the bare minimum steps that you need in order to get the environment going. So we just cloned the environment repo, right? Now we're going to grab from the GitLab templates directory in this repo, in the IAC AWS platform repo, we're going to grab a couple of files, right? we're going to get the workbench config file for the version of mojaloop that we're going to run, which in this case is going to be 14.1. And we are going to copy the backend.hcl file, and we are going to get the GitLab pipeline file, and we're going to put those into the repo that we just created, and that will be our task for right now. So this is the FinTech SBox RW repo that we just cloned. Let's go in this repo and let's go to the GitLab templates directory. And you notice that there are CI templates and switch IAC. CI templates will be the actual pipelines definition that control how the GitLab CI runs the different jobs. And in the switch IAC, we have an example GitLab CI file and the different workbench config. Okay. And so this, sorry?
In one of the earlier, I think earlier you mentioned, we may be able to use one of the existing sandboxes as reference. So is it possible that we can clone that and just update any config and by pushing it, be able to replicate that, or should we start like this from the templates?
Well, we can do it that way, but the problem with that is that what we have as an example to work off of is the dev environment, which has active dev going on.
Yeah.
And so versions have been bumped, and it would be a lot easier for us to start, since we want a 14.1 vanilla environment, it would be easier for us to start from scratch as opposed to trying to figure out what has changed.
Okay, yeah, makes sense.
These two directories here that you see, so effectively, this is the skeleton of what you would see inside of a GitLab repo for an environment. The workbench, one of these workbench config files, and for us, it's going to be the 14.1, the GitLab CI file, and then these two directories are what you can use in order to override certain values and Terraform files for the switch IAC as well as for the payment manager K3's cluster IAC. And we'll talk about that in a bit. But effectively, these directories mirror the IAC code directories and allow you to make changes, overrides to the code. And this code is versioned, so you could say, I'm going to use version 3.2. whatever, and then once using that as a base, now I'm going to override certain Terraform files, or I'm going to change the versions that are listed in the .env file for the K3's cluster, for example. So this is where you would make overrides to the IAC templates. And again, there's two directories, one for the switch IAC and the other one for the K3's payment manager cluster.
Okay.
All right. So I think the easiest thing to do is that we'll take this file here, and we're going to use, most definitely we're going to use that. So in here, let's create a new file. Let's call it the workbench. And let's paste that in. All right, so what does that do in a nutshell? That sets all the versions, the tenancy name, the environment name. So there are things that we're going to have to change here. So referencing the environment name that we set here, we're going to use that in our workbench config. right? The client name, the tenancy name is the same, labs. The region, this is the same region that we're going to use. And then the rest is a bunch of versions. And most of this is.
Okay, see some tags there.
Which one? This?
They're also okay. Those are the versions as well for GP and various test collections.
Correct. These are the references for the different repos that contain the test collections and
Yeah, makes sense.
the version of Kubernetes that we're running, and then bulk enabled, third party enabled, ETK SIMs enabled.
Cool.
So now, actually, let us be careful here because we should not be on main. We should be on a tagged version. And we should be on
30. Okay.
302. Because I saw things there that were recent additions. Right? So let's go back to GitLab templates and oops, sorry. Switch IAC 14.1. Let's copy that again. Okay. Now, fix the sandbox. All right. Now we do have some tags for costing. So we have a cost center and we have an environment. I think we can put that in there. And you're the owner.
Okay.
And outside of that, that is pretty much the base configuration for running 14.1. All right. So next file.
Cool.
We're going to not there. We're going here. And I'm going to copy that. GitLab CI. And we will bump that to all right. Now we can take one of the other environments and we can compare. You can see that we have not named that correctly. All right. And these sync directories are not needed if there's nothing that needs to be overridden. Now, these two files here, these two files we're going to make use of. And you notice that they're inside the K3 sync directory.
Right.
So here we're going to create a new folder. All right, now here I've just done a copy and paste, and that's probably not a great idea either. One thing that I do want to, I'm trying to think what the best way forward here is. I'm sure that there's been changes to the environment file. Yeah, for what VJ's been doing.
Okay.
So let's take for here, let's take the environment file from here. Okay. The K3's cluster is a completely separate cluster, and it's in a different VPC. And so in order for GitLab to be able to communicate to private endpoints within this cluster in order to drive tests, we actually allow the VPC where GitLab is running to access the VPC where the K3's cluster is running. So because we do that, and each environment has its own test K3's cluster, just as a default, the VPCs that we pick for running the K3's cluster have to be unique so that we can route the traffic correctly from the GitLab CI to the K3's cluster. So what does that mean? That means if you look at the different environments that are there, you have to pick a unique VPC CIDR.
Right.
For instance, here, right, we're using 107, and the upgrade test was using 109. So if it's not running and it's been destroyed, there's no issue. You could reuse it, but just to be careful, we should use a unique CIDR. So here I'm just going to bump this to 110. And that's basically all the changes that we need to make for this configuration file. And then the extra tags, again, these are the tags that are applied to the AWS elements of the K3's cluster, not the switch. So similarly to how we set up the tags for the switch in the workbench config file, which is here, we are going to set the same tags here. All right, so we have the .env extra tags in the GitLab CI file and the workbench config file. All right, so now we have created the basis for the environment, and now we're going to want to commit those changes. Let's sync those changes and head back over here.
Cool.
All right, so now they've shown up here. Let's look under CI/CD. Let's look at the pipelines. It is not configured to run anything on a commit. That can be changed, but the default is that all these are manual. If we wanted to make sure that like a base or base configuration for everything is sanity checked, we can run the validate and plan. And all this is going to do a Terraform init, validate, and plan for the first step of the infrastructure build, which is to build out the VMs and the other underlying AWS infrastructure. Yeah, so you can see it's pulling the Docker image that we tagged the version 302.
Yep.
So the first time it runs, it has to pull that. Okay, so it did the validate and it did the plan. And it actually will save the plan file in the cache. But we're not actually making use of the plan file, but you can see the kind of elements that will be created. It's worth saying too that I mentioned we went over the choices in the K3s cluster for changing the size of the agent and the master. But there is also the corresponding configuration changes that you can make in the switch, right? So if you wanted to change, I'm in the wrong place here. Keep doing that. So you can see that the cube worker size is set to this, the number of workers set to 3. And so you can make those similar types of changes here in case you need to reduce or increase the size of the cluster that's created. So anyway, I just wanted to make sure to point out the ways that you can save costs depending on the load that you are expecting.
Right.
So let's go back to the pipelines. So we've done the validated plan. This will show green in this view. It'll show that that's the only process that has started. All right. So this deploy all, I would say it is about 98% complete. I'm still working out a couple of issues, making sure that this is completely functional. So I would stay away from using it for right now. We are going to step through the process manually. So the way that this works is the deploy infrastructure is executed, then the deploy platform is executed, and then the tests can be run in pretty much any order, or you don't have to run all of them. You can run whichever one you're interested in. But the first two steps, the first step is to create the AWS infrastructure, and this is for the switch. So exactly what we did over here in the validated plan step, this is doing a Terra grunt apply of that same code. And the reason this one needs to go first is that we need to set up the AWS infrastructure for the switch. And we're going to make reference. Well, let me think. I don't believe there's any reason. So we make a routing rule between the gateway and the K3s cluster. So it shouldn't matter. I'm just thinking off the top of my head, Sam. I believe that we can run this step concurrently. So as these jobs are running, you'll see a little time window here indicating that it's still running. You can always click onto these jobs and see, right? So here it's a bunch of load balancer elements that are getting created, the AWS instances for the workers and the masters, they've been created. So anyway, this is going to continue for a while. Back to the K3s cluster. Right, so there is some information that we're pulling from the first AWS step that needs to be parsed for the create K3s cluster. So my suspicion was correct. We need to wait for this, and then we can run the rest of them.
Okay.
Here's a list. Deploy this, create and run these two in parallel, then base services, then this, then this, then this. So this has the ordering.
Right. That's okay. Thank you. Okay.
All right. So this took almost 5 minutes.
Yeah.
All right. So let's go back to the pipeline, and now we're going to kick off the create main cluster and create K3s cluster.
Okay. So I definitely like this separation, because that replicates how things need to be separated, ideally. So yeah, I like that approach, even though I think in some cases everything is deployed in a single cluster. Maybe that's for different purposes, but this enables it to be used in even higher level environments as well.
Which part?
Separating out the main and K3s cluster.
Oh, yeah. Well, I mean, in theory, right, you could have one K3s cluster that you could use for testing multiple environments. So you could have a separate project for running the K3s cluster, maybe, and then deploy your different payment managers that some of them would point to dev, some would point to test, and you could minimize the number of K3s clusters that you had to spin up.
Mm. Yeah.
All right, so now it's a race of the clusters. Each of them take about 10 minutes to finish.
Okay.
So the K3s cluster has already finished its Terraform creation steps, and now it's into Ansible to start spinning up the actual deployables onto the VMs. If we look at the main cluster, we're also into this has all been 4 minutes of Ansible running Kubespray. It's a much heavier weight distribution of K8s than the K3s is. And it's worth saying also that the version of Kubespray is baked into the image. So if we look at the platform code, I'm going to be careful to be on the right tag here. And you look at the Docker file, you'll notice that the Kubespray version and the K8s version are baked into the image for the. This is the image that the GitLab CI uses to run the job. So as a part of this image build, Spray is downloaded for this version, and so when the pipeline actually runs the Spray install, it uses the version that's inside the image. I'm just making up stuff to say while we're waiting for the cluster to finish building.
Makes sense. And I think it also, looking at those versions also shows us that we've been using the latest Kubernetes version that tooling supports kubespray in this case. So
yeah, there could have been some changes over the last month or so.
Yeah, this was 14.1, so yeah. For V50 it might be 1.25 or 2.6. Yes.
Mm-hmm. Okay, so Vault is being installed in K3s. It's made use, Payment Manager makes use of Vault. So it looks like that this is getting pretty near the end of the installation for K3s. After so many logs, if you want to see the full log, you need to click on that. That will show you all the details. I think it's worth looking at the Route 53 while we're doing this. So you'll see the zone that got created for our environment. And no records have been added to it as of yet.
Okay. Yeah.
But going forward, as we're looking at the URLs to link to connect to for the various portals and what have you, you'll see these get populated in this zone, right? And there's also a zone that's been created for the K3s as well, which is this one here.
Yeah.
Now here you'll see that there's already been various host names that have been registered within DNS for Grafana, for Vault, for WireGuard, etc. All right, I'm expecting this to be finished within the next minute or so.
So have you do you usually, or do you encounter any issues, errors until this time, like as part of setting up the cluster?
No.
Okay. So typically the issues you see are only during actual deployment of mojaloop services, not in the infrastructure as such, is it?
Yeah, I mean, once the development is complete and been tested, I don't even see really issues with that. So
no. Sys job succeeded.
Yep. All right. So K3s was much faster, right?
Yeah.
Okay. So let's go back to the pipeline. We have our two Kubernetes clusters created. Now we're going to start deploying base services, which means let's encrypt, cert manager, Vault, external DNS, storage, not storage, but when let's kick it off. and we can review the different services that are created here. So now everything here needs to be run in order. We're not going to run anything in parallel.
So are you connected to any VPN to access?
No.
Okay.
So if we look at the Terraform, right now, what we've run through, we ran through the base infra AWS module. So we ran this. Then we created a cluster on top of it via Kubespray. And now we're using this module, the base K8 setup. So external DNS, we have a certificate manager issuer for Let's Encrypt. And we have ingress controllers. We're deploying console as a backend for Vault. We're deploying Vault. Cert manager, as I mentioned before. And we have an internal and external ingress controllers. And our storage is Longhorn. So that's the configuration of Longhorn. This is for the S3 backup for Longhorn. And so that forms, this module essentially groups together the base deployments that rely on AWS, right? So you saw in Longhorn that we're using S3 for a backup. So that requires S3 AWS IAM credentials for S3 permissions, as well as the bucket creation. And then for external DNS, right, we have to create similarly users with policies for Route 53. And Let's Encrypt is also going to rely on Route 53. And then the console relies on having a storage class defined through Longhorn. But other than that, the reason it's here is because Vault requires AWS credentials for unseal key so that you can automatically install Vault and unseal it without manual intervention. So this base K8 setup here, this is where the components that need to be installed that have dependencies on AWS, right? And obviously the base infra AWS, this is very dependent on AWS because this is creating the underlying infrastructure in AWS in order to then deploy the Kubernetes cluster on.
Yeah.
So then everything else that's in here is independent of AWS. So as we talked in the last couple of convenings about cloud agnostic version of IAC, this is the first release where those are all separated so that somebody who wants to re-implement this using Azure would re-implement these first two using Azure, for instance, or GCP, or the equivalent for bare metal. And then these pieces in here, which are the actual mojaloop pieces, would be configured, would be independent and would be unchanged because they're just relying on the underlying Kubernetes cluster and services that are being offered. So here we're getting to the ingress controller. All right. So Vault is installed. We're done. So now we're going to deploy the stateful services. These are the databases that Mojaloop and its related services require in order to function. And with version 14, the separation of stateful services from the Mojaloop Helm charts was completed, and the IAC had already separated them out. So this is the step where we're actually deploying the stateful services, the databases in Kafka and Mongo and what have you. And you can actually see those. So here is our workbench config. Right. And if we look, we have a section here called stateful resources. And these are of various types. So Redis, this is MySQL. This is another MySQL. And then further down, we've got Central Ledger Database, Keto, so the Ori stack, Kratos, again, Ori stack, Mongo for bulk, Central Event Processor, Mongo, reporting events, Kafka. Okay, so those are the definitions for all of these databases that need to be created. And what happens after they get created, here we're specifying how they'll be created on the cluster. So we're saying it's going to be this Helm repo, this chart, this version of that chart, and use this values file within the templates directory to build that. And whether we want a random password created, etc. And then an external service is created for this local resource that allows the Mojaloop code base to access it in a let's call it implementation independent fashion. So if you wanted to run Kafka as a managed service, which is probably not a great idea because it's very expensive, you could, and then you would define the external service here. And then inside the cluster, this will still be advertised as the same service locally to the cluster, but it will point to the external service. And so this gives you a level of decoupling between where the external services live, so that your code base is not tied directly to whether you're running in your services within the cluster or external to it. Okay, so we should have looked at this a little bit earlier. There's a wait step waiting for the wildcard cert to be ready, and this is from certificate manager. So let's retry, because it's going to continue to wait until that certificate is ready. Okay, so it was the conditions already met. So it took a while. You could increase this timeout here in the future. But generally that certificate gets created pretty quickly. So now it's actually going to start creating those staple resources that I was assuming was already happening. So while running this, I am going to show the S3 bucket, contain the contents of the S3 bucket where we're maintaining different files. So I'm syncing S3 here, and this is the location where we have our tenancy. And if we look in the folder for the environment that we're building, you'll see different folders here. One of the folders is K8s. If we look in K8s, we'll see the admin. So essentially the root kube config for the switch cluster. So in order to access the Kubernetes cluster using this configuration, you need to be on the private network of the environment. And the access to allow private access to the private subnets of the tenancy is through the WireGuard instance of the tenancy.
Okay.
So I'll pick this up after we start the next job. So we've done creating all of our stateful services. We're going to move on to what I call support services. This is like WSO2 and HA proxy and Grafana and Loki, etc. So how do I, as a switch administrator, I want to log in to the cluster, see what's going on. I need to have WireGuard installed on my local machine, and I need to create a profile for accessing it.
Okay.
So we go to Labs mojaloop Live. We'll be presented with this portal login screen. The password is you need to get from the output of the Bootstrap Terraform. And obviously I'm not going to show that on this screen while I'm sharing, but I will off screen grab it, and we can keep the command. You can put the command in the notes for sharing. And so you can see the various clients that have been created. You can create a new client, and then you can download that profile, and then afterwards you apply config in order to make those changes permanent. So that's where you go to get a profile, and then once you have that profile, you have WireGuard client running. I am active. Okay, so that shows our nodes. Scroll this over. Here are all the pods that we're running.
Okay.
So right now we have installed Loki, Grafana, Prometheus, doing a bunch of Vault setup in order to support Connection Manager. So I should also mention that, as I said before, we have the DNS zones that have been created. And so let's do not sandbox. Let's do FT, right?
Okay.
So this is the Vault instance that's running as a part of the switch. We also use Vault to manage the secrets that we generate for the stateful services, etc., as well as portal accounts. So if we want to connect, we choose OIDC as a connection method. And we use this role. This will go back to GitLab and ask if we want to use our GitLab account to authorize access. So now we've authenticated to Vault without using any tokens. We're just using GitLab to authenticate. And as far as secrets, I was mentioning that the various secrets for Grafana, for Connection Manager, mojaloop, etc., and all of the databases that we created. So in mojaloop, we're going to have, ALS, MySQL password, and the root password, etc., for all these different stateful resources. Those are all stored here. All right, let's see how our support services is going. Looks like it's done. Yes. All right. So now we have everything. The bases have all been completed. Now we're going to actually install mojaloop. So what we have is we have a monitoring solution in Grafana, Prometheus, and logging via Loki. We have WSO2 as an API gateway, and the identity management solution for DFSPs. We have Connection Manager for managing the onboarding of DFSPs, with very tight integration with Payment Manager. So I was mentioning the tools that have been laid down. We have the Longhorn storage with S3 backups. We have the Grafana tooling with Loki and Prometheus, which gives us the monitoring and the logging. We have WSO2. We have Connection Manager. And we have Vault, which is, I just showed, we're managing our secrets there, as well as the configuration for the mutual TLS, for the end-to-end security for DFSPs through the switch. So that also includes managing certificates both through Let's Encrypt as well as Vault. And the other tool I wanted to show while we're waiting for Mojaloop to deploy, which is not just Mojaloop, but also the uh, business ops framework portals.
Right.
Uh,
The finance.
I want to show Grafana. So we're going to also sign in with GitLab here. So again, no sharing of credentials. Everything is driven off of group membership of users within GitLab. So there are tenant admins and tenant viewer groups. Tenant admins will be allowed to admin both Vault and Grafana, and tenant viewers are only allowed to view limited amounts of information. So within Grafana, we have access to both Loki and Prometheus. So there are dashboards that have been set up, and they are configurable. But you can there's nothing set up for Loki, but we do have trying to find out search dashboards. Okay, so here we have the dashboards that come out of the box. They need some work. They need to be updated. They haven't been touched for quite a long time. So some of the information is not relevant, but those workbench configs are a part of the IAC, and they can easily be updated and added. You can add custom dashboards to your deployment if you want. So, and the Loki um, view does allow you to query logs across all the pods in the cluster. So let's go back to our pipeline. So here is a view from using Lens. Here's what's running in the Mojaloop namespace. You have some account oracle spinning up. Simulators. BOF. So the business ops framework elements are starting to come up. All right, we're getting close to the end. So I'm going to show connection manager. As I mentioned, I have one more step before I can log into Connection Manager. We look to be almost done. These are adding the roles and permissions for Business Ops Framework. And this is publishing the APIs, the Mojaloop APIs to WSO2. All right. So now we have one last step, which is some post config, which is actually creating some configuration for the test payment managers that we're going to use for running the end-to-end tests. And this will also provision the hub operator account, which I'm going to use to onboard the payment managers once we deploy them. Okay. So let's go back. And we're going to go to Connection Manager. And we're going to log in. So here we have the four payment managers that have been provisioned within Connection Manager. Now they haven't been actually fully onboarded. And I'm just going to quickly show that in this file, the workbench config file, we have the definition for the what are called internal, probably a better name is test payment manager configs. And you see the PM4ML, receiver, sender, demo wallet, demo MFI. Those are the four that are here. And if you want to add more, or you want to change them or remove them and add your own, this is where you would do that. In order to run the canned tests, some of these are necessary. Just disclaimer, you can't expect the test to run, all the tests to run if you remove these from the configuration. Okay, so where were we? We were at the last step. So we're going to install the internal payment managers. So this, as all the stuff that we've been doing has been on the switch cluster. The create K3s cluster created this test cluster for just for the payment managers. And this step here is now going to deploy those 4 payment managers that we just saw in the workbench config onto that K3s cluster. And it's gotten a little bit of information from the pipeline as to, well, where is this switch located? What are some of the endpoints that I need? And also, what is the credential that I would use? So we missed a file to copy over. I'm going to grab that from here. Let's commit that. Let's go back to a new pipeline that's been created because we want to make sure we're using the latest repository files with the new file that we just added. Come back here and start that again. Our payment managers are deployed, and that's the last step of our deployment. So now those connection managers are installed. Now they're trying to connect to connection manager in order to trade their certificates and their IP addresses, etc. So you see here we have 4 CSRs that have come from those 4 payment managers. Now we're in connection manager here. And we're going to sign each of their CSRs. And then we're going to go to the DFSPs here. And we're going to press this button to onboard each of them. And effectively that takes the IP address and the certificates, as well as the endpoints of the different payment managers, and the client certs or the switch to use to call the payment managers, and adds those all to Vault. And then WSO2 and HA proxy, as well as Nginx, use that information in order to allow access and configure egress access from the switch. So now these payment managers are onboarded, and we're going to give them a bit in order to configure their tokens from WSO2, etc. Meanwhile, if we go back to the pipeline, we can run the TTK tests from this step here, number 4. And after we run that, we are going to check running the payment manager golden path test. All right, well, there were some failures there. Now we're going to try running the end-to-end. Okay, so the end-to-end payment manager test ran without failure. So yeah, we've kind of seen the different components involved, how to use it for a few things, accessing Grafana, connection manager, running the pipeline, running tests, the deployment of everything.
Yeah. It's a lot of stuff. I think that covers that all. Yeah.